We should understand the story behind data and data engineering. Then we'll be unpacking a couple of major challenges that we face with data every single day, including data storage and data processing. And after that, we'll be going through the data cloud and how the cloud will help us solve these problems. And at the end, we'll be exploring the career in data engineering and within the Google Cloud ecosystem. We'll also do a hands-on lab together. So if you have access to Google Skills, we can do it all together, or feel free just to watch my demo. So let's get started. Uh, the story of data. So what is data? In the context of data engineering, I always look at the data as the building blocks. But if we want to take a look at it from as the books says, data is a collection of facts, figures, or observations. It can be structured, like in an Excel sheet or a SQL database, or unstructured, as in a graph or a tree or something like that, or even an image or video. And there's a very important thing to understand is that data in its raw form, as we capture it, it often lacks meaning, which means it's simply useless. Unless we do some sort of processing, we do some work to better understand it, add value to it, it's simply useless. If we look at the amount of data that we create every single day, look at this graph, and we can see how our data accumulation has exploded since 2020, since 2019. This is actually the time where a lot of enterprises have started to move to the cloud, simply due to COVID. And if we go back to 2016, we find another like slight increase in the rate of data accumulation. And this is thanks to the major cloud providers that were stable enough at that time, including Amazon Web Services. Google Cloud was just starting back then. So if we just take a look on this data in zettabytes, simply 1 zettabyte is almost a billion terabytes. So that's a lot of data that we accumulate every single day. So that's an overview on how big is the data that we accumulate every single day. So what is the data engineering? It's simply the transformation process. The blocks that we have, we shape them in a better form that we can understand, that we can make use of. But by the book, data engineering is the practice of designing and building systems for collecting, storing, processing, and analyzing data at scale. And the word at scale is very important here because when we say at scale, we're talking about big data. We're talking about wherever the scale we have, our systems are able to collect, store, process, and analyze this data wherever the scale. The key responsibilities for any data engineering team comes in building data pipelines. We'll take a look how these things are built. Also ensuring data quality and reliability, because these days, if the data is not in good shape, or lack reliability, we can use it for machine learning. We can't use it for driving decisions, having insights, understanding our world. Also managing the data infrastructure, because these things needs a lot of infrastructure, a lot of compute power. Also making data accessible to data scientists, analysts, and other stakeholders. So simply, if you're a machine learning engineer in a big enterprise, you're most probably to be dealing with a data engineer who's gonna prepare the features for you or prepare the data for you so you can train your model. So if we look at the data engineering lifecycle, it always starts with a source. It can be an IoT device, it can be a social media platform, it can be an API, it can be an Excel sheet. Any form of data in its raw form, it's called the source. This source will provide the data, and our responsibility as data engineers is to ingest this data into our platform. In today's context, it's going to be Google Cloud. And this ingested data has to go somewhere. Like just like when you get some milk from the grocery store, you need to take it somewhere. Of course, the refrigerator, or you're gonna lose this milk. So we have to store it somewhere. We need to find the right solution to store this data. The solution that's suitable for its form, for the performance that we look for the kind of data that we have. After that, we're gonna perform the transformation. And this is where the essence of data engineering comes. Because transformation is the stage where we add the actual value to this data. Before the transformation, most probably the data is useless. So once the transformation is done, it has to go somewhere. So we've done the transformation, it should go to a proper storage solution that's going to ensure that this data is served in the best form and the best quality we can afford. Okay, so with that being said, data engineering is actually important, and these days it becoming more important as we're adopting AI, and AI heavily relies on data. And if we have bad data, if we have corrupted data, we're gonna have garbage as an outcome for AI. So it's very important to have well-structured data, well-managed data, high-quality data in order to get better AI experience, better AI adoption with our organizations. Let's jump into the data storage pillar. So in the world of data engineering, there's actually a lot of storage solutions that we can use in order to uh, store our data after ingestion or serve our data from after transformation. But the most common two solutions that we rely on as data engineers are data lakes and data warehouses. These two are storage solutions, but they have completely different purposes. In terms of the book definition, if we look at the data lake, it's simply a centralized repository that some or enterprise would have to store vast amount of raw data. So the data lake most probably is used to store the data after ingestion, to manage huge amount of data, store it for long-term retention, stuff like that. But if we go to the data warehouse, it's a centralized repository that stores structured, processed data from various sources. So for the data warehouse, it's simply used for the serving side. This is where we put our data in the most structured form in the best format that we can put it into in order to make use of it. So if we want to run reports or solve reports or management, or want to have data-driven decision making, we should absolutely rely on the data warehouses for managing our data. And the difference between both of them comes from the kind of data that's stored inside of them. So the data lake is designed for the unprocessed raw data, wherever it's type. But the data warehouse serves as the destination. This is where we store the structured, processed, or transformed data. In terms of schema, for the data lake, it's set on the read, but for the warehouse, the schema is set on write. And if we compare them in terms of the users that they use them every single day, we see that the data lake is more of an engineering tool, but for the data warehouse, it's more of a business-centric kind of tool. And if we compare them in terms of price, as the data lake is designed for more storage but less performance, it's like understandably comes at a lower price compared to the data warehouse that is optimized for performance, for getting the right piece of information as fast as possible. So we took a look at the storage solutions that we should use as data engineers, but how we actually perform the data processing within a data pipeline. We have three ways, like three commonly known ways for data transformations. The first one is EL, the second is ETL, and the third is ELT. Let's take a look at them. For the EL, which is the extract load, simply we have a source and we load the data of the source into the destination immediately. But the transformation that we can perform on this data is very minimal. For example, if you have an Excel sheet and you want to load it into, let's say, some sort of let's say another Sheets solution, for example, Google Sheets, that's an EL process. We don't make any changes to the data that is inside of the sheet. We just change its form from the source language to the destination language. It's very useful, especially when we migrate a database or we have a copy of something that we want to start working on. But for the ETL, this is where things become more actionable, because we have a step in the middle that is the transform. We extract the data from its source, regardless of this source. It can be a data lake and it can be a data warehouse. We perform a lot of transformations, and then we store the new form of the data into the destination storage solution. So as an example, if we have a sheet that has, or a database that has users' credit card information, and this kind of information should not be exposed to any form of users, including the company's business analysts. So simply we perform a transform process that's gonna remove all these PII and load them into the destination, which might be an Excel sheet or might be a data warehouse that the business analysts at that company would use. The third form is the extract load transform. This form is a bit modern because it comes with the modern um, data platforms, including Google Cloud. And here, what we do is we load the data into the destination immediately, and it can be in its raw form, or we make minor changes. And after that, we can have the transformations on this data on place. So we can make the changes and transform the data into a useful, let's say, format within the same data warehouse. And this is where BigQuery comes in handy. We'll talk about it in a bit. Um, if we're to compare the data pipelines, but from a different perspective, how things are moving, the data in motion, we have two types, the batch processing and the streaming processing. For the batch, this is for the processes or for the transformations that is not time sensitive. For example, if I have a process that has to be processed, for example, overnight, this is also useful for bigger chunks. If I have like a quarterly reports that I need to generate based on a lot of data, I can run a batch process overnight. It comes in a higher latency, of course, but it can process bigger chunks of data at lower prices. But when I have like a time sensitive use case, for example, the CEO wants an answer for a certain question based on a lot of data, this is where the streaming comes in handy. It can be performed on a smaller chunks when we compare it to the batch, but it's served on a very lower latency. Like for example, we can process the data as they come. Like this is for super useful when we have live dashboards or we have fraud detection processes. Like whenever we're traveling and using Visa or MasterCard, if Visa captured an abnormal usage of our credit cards, they would immediately block the transaction. This is how the streaming pipelines are useful, because Visa was able to understand or at least identify that there's an abnormal transaction on our account or our credit card. And after that, it was able to protect our cards. Okay, let's take a look at the open source processing tools that we can use for, let's say, data transformation and data engineering. We have Apache Spark. Apache Spark is a distributed computing framework that we can use for processing big data. It also supports batch and string processing. And I can consider it the bedrock for the modern data engineering pipelines. If we want something that is more abstract, more straightforward, um, we can go for Apache Beam. Apache Beam is a unified programming model that we can use it to build batch and streaming pipelines. And it allows us as developers to write data processing codes once and execute it everywhere. So you can write Apache Beam code once and run it in Google Cloud, run it on AWS, or run it somewhere on premises, or even on your computer. But these technologies are amazing, but if we don't have the right platform to power it, they're actually useless, because if you want to process big data, you need a powerful platform that can perform streaming processes so fast or handle terabytes or petabytes of data. And this is not what your computer or normal desktop can do. So This is where the cloud computing or the data cloud comes. If we want to go for like a quick brief on a cloud computing, it's simply any service or any computing service that we can get over the internet, whether it's servers, storage, databases, analytics, intelligence, you call it. We have three major providers, like globally, we have AWS, Google Cloud, and Azure, but we'll be focusing on Google Cloud for today. And the cloud has a lot of use cases, but our focus today will be on data engineering and data processing and smart analytics. So, uh, why would we be using Google Cloud for data engineering? The main thing is the scalability, because we mentioned that we want to perform our tasks as data engineers at scale. So wherever the scale, the platform has to go up and down with me. Innovation, getting the best of what we can get from the market, uh, like whenever it's available. Integration, Google Cloud offers great integration tools within its ecosystem and with other ecosystems. It offers uncompromised security and durability for data, as well as availability. Okay, so if we look at the data management solutions for Google at Google Cloud, which are the bedrock of data engineering, this is where this all the story starts. We have multiple solutions, including cloud storage. It's useful for implementing a data lake. We have a cloud big table, a cloud data store, cloud SQL, and cloud spanner. And all these are data management solutions. If we want to compare them by data or by the data type that they store, cloud storage is designed for any kind of data, blob data. If we look at Cloud SQL and Cloud Spanner, they are optimized and designed to store relational data. So if we have a SQL database, Postgres, MySQL, we can store it on Cloud SQL. And if we have a horizontal scale and global availability for our data, we can go for Cloud Spanner. For non-relational databases, we have Cloud Bigtable, which is optimized for very low latency workloads, and Cloud Data Store if we have like mobile applications and stuff like that. Just for context, a relational database or relational data comes in tables for the great majority of the time. But for the non-relational data, it can be in graphs, can be in documents, key value formats, and stuff like that. So this is how we manage our data on Google Cloud. Let's take a look at the implementation of the concept of data lake on Google Cloud. So we'll be using cloud data storage, and cloud storage serves as object-based storage solution. It provides scalability and elasticity. It's very cost-effective and has security and access control features that are world-class. And this is a quick overview of the console of cloud storage. It's similar to Google Drive if you think about it that way, but it's for enterprises. We're gonna see it in the lab in a bit. For the data warehouses, we'll be using a solution called BigQuery. BigQuery is a platform that we use for building a data warehouse. But what's great here is that we can implement this data warehouse on a serverless architecture. So there's no servers provisioned all the time for us to run our queries. Whenever we run a query, we get the compute power, and whenever we're not running queries, we don't pay for compute power. It's allocated to someone else. And what's great about it is that it's SQL compatible. So any data analyst can use it from day one. It won't be that hard for them because anyone who can speak SQL, they can use it easily. This is a quick look of its console. As you can see here, we can run SQL queries and get results here. And we can go as complex as you can think in our queries and our SQL processes. We'll see that in a lab in a bit. How about the transform stage, which are the implementation of data pipelines? Google Cloud has multiple solutions, but we'll be taking a look at three of them. We have Cloud Data Fusion, Cloud Data Flow, and Cloud Data Proc. Cloud Data Proc is simply a managed Apache Spark. We've talked about Apache Spark a few moments ago, and it's designed to migrate legacy pipelines from on-premises to Google Cloud and provides us with a lot of flexibility in terms of the compute optimization and stuff like that. Meanwhile, it supports batch and streaming processing. For Cloud Data Flow, it supports Apache Beam. So if we write an Apache Beam code, we can run it immediately on Cloud Data Flow. And it provides us with a ready-to-use templates. So it makes our work a lot easier. And it supports a serverless architecture. So we don't have to think of the compute power and the provisioned servers that's gonna do the processing. Google Cloud will build these pipelines for us just from our code. Okay, for Cloud Data Fusion, if anyone who don't like write code, this is your solution. It's a visual code-free interface, and it's of course serverless, so we don't have to manage any servers. And it comes with pre-built connectors, so we can connect our pipelines to different data sources and data destinations. It's very useful if you want a code-free experience. So that's the difference between these solutions. Let's build a quick pipeline. And let me introduce you to a very interesting use case for implementing data engineering on Google Cloud. Anyone heard of Goldman Sachs? Okay, so Goldman Sachs is an investment bank. It's based in the US. So I'll leave you with this quick video that is going to discuss the use case that Goldman Sachs is implementing on Google Cloud.
Goldman Sachs is a place where macroeconomic events are studied and analyzed, where transactions are conducted, where risks are measured, the kind of momentous things that show up in the front page of important newspapers.
Goldman has a long history of being creative and innovative to service clients' needs.
One of the things that we really pioneered was bringing financial mathematics to Wall Street. Historically, we held insights that we garnered from our own technology within our own four walls. As the world has changed, we're trying to share that more openly and transparently with clients. We're approaching brand new problems, building brand new businesses in spaces we haven't been in before. These are big moves for us. You have to have a certain level of agility because things change fast.
That's very important for us to be able to handle that demand as quickly as possible. Seconds, milliseconds all matter.
We are a wholesaler of risk. We need to be measuring, factoring, analyzing, and monitoring risk. And it consumes a lot of compute power.
How do we maximize the compute power? How do we execute things faster? This is super critical because we are a global business.
There's nothing more precious than our reputation, how safe clients feel in dealing with us, how we guard their information. It's absolutely imperative for us to be on the leading edge there and pick partners who we can really rely on in those domains. As we thought about scaling our own business and how much more intense that risk management activity could become in the world, Google was an obvious choice.
Google has a very good track record building large-scale services with security in mind.
Any platform like Google Cloud can allow us to kind of refactor our human capital and focus on solving client problems is really valuable for us.
You basically have all these building blocks already existing that Google provides you that helps you to build a product faster, that helps you evolve faster. So that is super exciting.
You know, one of the little known things about Goldman Sachs is that 1 out of 4 people here at the firm is an engineer. We really think about it as conferring superpowers on our people. The ability to understand data faster, to express ideas faster, and to be engaged with clients. Google's capabilities are so extraordinary. The way that we factor compute cycles, the way that we express our technology, the proximity of that technology to our clients, their ability to access it directly, that's been transformed dramatically. Goldman Sachs prides itself on taking a very long-term approach to developing client relationships. I've been really struck at Google taking a very similar approach with us. That willingness to invest in the relationship between our firms is really differentiated. Google's been able to both meet our needs in the moment and yet also be a great thought partner about where this could go over time.
Okay, so we've took a look at um, how a huge investment bank is utilizing Google Cloud to run multinational investments and provide top-class financial services for its customers, and how critical is data is considered for this bank. They deal mostly with sensitive data, and they're talking about petabytes of rich data that has to be analyzed. Of course, they value the innovation. Also, they have fluctuating compute demands. So you will see them in the morning analyzing or performing heavy analysis on a certain market, but maybe in the night they have different needs. So this change in compute uh, is very noticeable in their case. So if if we look at such a problem as data engineers, uh, we would see a lot of things to solve, a lot of problems to solve. And this is our work as data engineers, to understand such problems and perform our work in order to get our customers or our employees to to a better decision making experience, and more recently and these days, providing them with uh, better experience to adopt AI. So let's take a look now at our lab. We'll be doing a lab together. I'm gonna share the link here in the chat box. If anyone has access to the to Google Skills, feel free to run the lab with me, and we can solve it all together. If you'd like just to watch the demo, you're also welcome. So let me share my screen again. Here we go. Okay, so this is our lab. It's called Data Flow Quick Start Templates. In this lab, we'll be building a data pipeline from a data flow template. So data flow, as we mentioned before, it provides templates for data pipelines. And we'll be using a template that takes the data in a form of messages through a solution called PubSub, which is a messaging service at Google Cloud. And it's gonna perform some sort of transformation on it. And after that, move it and insert it into a BigQuery table. So in this lab, we'll be creating first the BigQuery dataset and a table. Also, after that, we'll be creating a cloud storage bucket. This is where the data will be landing. And after that, we'll be running this template of this pipeline. So let's take a look on what we have as steps. We need to ensure that the data flow API is enabled. We'll disable it and re-enable it just to ensure that everything's going fine. And here we have two options: either creating the BigQuery dataset, the table, and the cloud storage bucket using Cloud Shell, which is the CLI way. If anyone loves command line, you can go there. The other method is through the console. For me, I'll go for the console just for the sake of having a better visibility over the platform. After that, we'll be running the pipeline on a cloud data flow. And after the pipeline is successfully done, we'll be submitting a query to BigQuery just to see the data after the transformation. So let's get started. So I go to the first step. Here they're asking me to enable and to disable, and after that enable the Cloud Data Flow API. For me, given that I'm using the console, I'll be going for the Data Flow API from the search bar. As you can see here, it's enabled, but let's just disable it from here. It's gonna take some moments to be fully disabled or to see the action reflected. I'm gonna go back to Data Flow API and enable it again. Okay, it seems to be already enabled. Okay, so now that we have done the first task, let's jump into, I'll go immediately to the third task because the second heavily relies on the command line. If you wanna do the command line way, feel free to do it. But for me, I'll go immediately for the console way. So I'll be going to BigQuery. You can access BigQuery from here. From the side menu, or you can immediately go through the search bar and search for BigQuery. It's up to you guys. Okay, now that we have accessed BigQuery, as you can see here, we have a lot of features for BigQuery. We have governance features, administration, migration services. Because BigQuery is an enterprise-grade solution, so you'd see a lot of stuff related to governance. I'm gonna go to the studio, and now I can see some details related to this project. But for now, we'll be creating a new dataset. And this dataset will be called taxi rides. So I'm going to copy the taxi rides and let's go and create this dataset. Nearby my project ID, and I'm going to click these three dots and I'm going to hit create dataset. Now I need to provide the dataset ID here. It's taxi rides. And after that, I need to provide the location where the data has to be stored. As per the lab's instructions, I'll go for the US. So the data will be explicitly stored in the United States. I'll leave the rest of the rest of the details as is. Here we have some encryption details, other stuff related to the data retention, but we'll leave these things as is. I'm gonna hit here and create the dataset. And as you can see here, we have the dataset created. Now we need to check our progress. And as you can see here, it's completed. And here, under the data, under this dataset, which is taxi rides, I'm going to create a table, and this table is going to be used as a destination. So I'm going to go here, the three dots next to the taxi rides dataset that we have just created. I'm going to create table. Here we have pre-populated fields. I'm going to add my table's name. As you can see here, it's under the taxi rides. And now we need to add the schema of this table. Here we have the schema of this table that we're gonna use. So under schema, I'm gonna enable edit as text. This will allow me to populate the schema of this table from raw text. So here we have it ready. I've just pasted. Here we have some settings for the partitioning, other for the encryption and data collections. But we will stick to the lab's instructions for now. And this is how it should look like. I just want to ensure that the text is set properly. It doesn't matter if you have a new line or not. And now I'm going to hit create table to create my table. And as you can see here, we have the table ready with all the fields within this table. We have the schema set with all of its details. I have here the ride ID as string. For example, latitude and longitude set as float. So we have everything set here. And our data warehouse is almost ready. Let's check our progress. Voila, dataset is ready. Now let's go and create our data lake. I'm gonna go for cloud storage. So I'm gonna search here for cloud storage. Okay, cloud storage. And under the menu here, I'm gonna go for buckets. The storage unit in cloud storage is the bucket, and anything within the bucket, any file that we upload is considered an object. So I'm going to create this bucket. Here I'm prompted to provide a globally unique permanent name for this bucket. I'm going to use the project ID. It's not best practice, but for the sake of learning, the names has to be meaningful in production. So make sure that you choose the name wisely because you can't change it after that. I'm going to leave the rest of the settings as is, but let's take a quick look on the settings that are available. Here we have them where the data should be stored, whether in multiple regions in the US or Asia or in the EU. Also, we have other options to store the data within a single region, let's say a single city, or a single zone, which is a data center or a Google specific data center. Here we have the class of the storage, and this decides how much I'm going to pay for the storage compared to the access of the data or the data retrieval. We'll go for the standard, but if you have data that has to be stored for longer times and accessed less frequently, you can consider other options. I'm going to continue here. Here we have the access control settings. I'm gonna hit continue, and here for the data protection settings, I'm gonna hit create and confirm. And now we have our data lake implementation ready. Gonna check our progress. Okay, now I'm gonna run my pipeline. Here we have this CLI command. Let's unpack it. It's gonna run a data flow job in a certain region with a certain compute instance. Here we have the staging location. This is where the pipeline will store the data temporarily. Here we have the parameters for this pipeline. We can specify them in that way. And all these parameters will be used to populate and run this pipeline. I'm gonna launch Cloud Shell. This is where I'm gonna execute this command. Now that my shell is ready, let's execute this command. I'm gonna paste the command here and run. As you can see here, the parameters are the input topic, which is the PubSub topic that's going to be used. It's pre-created, so we don't have to worry about creating a PubSub topic. And here we have the output table. This is where the data is going to go. So here we have the results. This is where they're going to go. Okay, so we have a problem here. Okay, it seems like the data flow API is not running properly. So let's go and ensure that these things are going right. Okay, it says enabled, but let's confirm that again. Okay, Seems like there's an issue with the UI, so I'm gonna use the command line to disable the API. And after that, I'm gonna re-enable the API and it should work just fine. Okay, we have just enabled the data flow API. Let's run the command again. Okay, now that this job is submitted, let's go to data flow and see how it's being executed. Here we have some details. It says that it's failed for some reason. Let's go and see what's going on. Okay, given that the job has failed, so there won't be any data to be shown here. Let's see if the other one. Okay, this one is starting right now, the new job that I've just created. I'm gonna go and see how things are going. Also failed. Okay, let's see the logs. Okay, again, it's an API problem. The data flow API is giving us a hard time here. I'm gonna try it one last time. Hopefully it works. Okay. So now it says it's starting. So starting. Might take a couple of minutes. Okay, here we go. Now our pipeline is executing. It's a streaming pipeline, and as you can see, we have multiple stages. Here we have it reads from the PubSub topic. This is where the messages are coming. After that, it's converting the message to a row in a table, and after that, it's gonna write this these messages or these rows to our BigQuery dataset. And the other stages here are just for checking if an error arises, just to ensure that everything's gone well. Our pipeline, as you can see here, is running and the type is streaming. Okay, let's go to BigQuery and see the results. So I'm gonna go to our BigQuery. This is actually our data warehouse. I'm gonna go here to the editor and run my SQL query. So this query is gonna get me up to 1,000 records from my uh, pre-created table, the real-time table. Okay, up until now we can't see any data in this table. Maybe the pipeline is still waiting for the data to come. It's going to take a couple of minutes before we see it clearly running. I'll go back to data flow and see if our pipeline is running as it should. Okay, it's been running for almost 2 minutes now. Here we have a couple of logs. Okay, voila. Now that we have the messages streamed into our BigQuery table, here as you can see, we have the write ID. We have some details about the write. That was in a JSON message and was transformed into rows into this table, as you can see here. So in this demo, we took a look at how we can implement a data lake and let's say a data warehouse. And after that, we've created a data flow pipeline from we've created a data flow pipeline from a template, and this template was to ingest messages from Cloud PubSub and write them into our BigQuery table. So now that we have completed our lab, as you can see here, you should expect 100 out of 100. You can put your knowledge to test here and in the lab immediately.
Thank you, Ahmed Al Ashraf, your lab presentation. I hope my attendee likes first, and it is really very good, and your explanation was very good. Okay, how important is data streaming and to build up the data pipeline while you are performing the data engineering roles. I would like to receive any question. If you have any question to ask my speaker, you can ask. I think so. There is no question. I would like to provide you some additional information. You know, though, there is a multiple event running through the Google Skills. Whoever join in the Google Cloud Arcade program, you can join with the Google Cloud Arcade program. Every month, Google Arcade program giving you the free credit as well as interactive lab that you can do hand-on practice. Okay, and also go through our speaker provided link to perform yourselves to go through in this lab step by step. If you have any problem, then you can either message to my alias rep, also you can message to me. I would like to love to help you as well. Okay, and thank you very much, alias rep, to joining with us and share your insight. Thank you very much. There is a more information regarding our GDG-SX. GDG-SX will welcome to everyone actually who try to share his insight that he feels it is so exciting things. Okay, if you feel you have built something interesting and you want to share with your community, you are always been the welcome. Also, we will have an Q in-person event, and there is a lot of things will coming that we are working behind the scene to give to our attendee and our community. So invite your friend to come and join with us so that we can build a very vibrant and active community. We are not just only to hear about any specific things. You can share your any perspective, like you based on your professional, your career development. Either you data engineer, either you security engineer, either you want to change your career. Okay, we will share with it and we will discuss it to find out the solutions so that everyone we can do something good and grow together. Thank you very much again to join with us. Hopefully we will join and stay connected with us. And after finish this session, you will receive a feedback form. Please don't forget to keep your feedback, leave us feedback for us so that we can understand you and we can improve our session. Okay. So it would be very grateful for us and as as for you. So thank you again to joining with us. Thank you, Ali Ashraf.
Thank you very much, Muhammad. Appreciate your time, and thank you for very much for GTG SX for having me. And looking forward for what's next. Have a good day.
Have a good day.